I decided to make the topic of this video about research. I think that's what this channel will be about. Um, right. Tech research, AI research. Right now, I'm looking into Java because I'm taking some Java courses. I'm immersing myself. So I was thinking open source project, AI, Java. Uh, Not because Java is the best and greatest. I mean, there's a lot of Android devices in the world. Um, When I think about not even usefulness, but like utility, Java is the first thing that comes to mind for me. Um, yeah, I've even heard like bigger tech channels question Java being taught. Uh, but thankful for me that I mean it wasn't the first language that I've learned. The syntax is interesting, um, and how it deals with really the placement of characters and I guess data types for the most part is I can see it being useful. So and how it does with memory. So right now I just found two random YouTube videos. They're about 10 minutes apiece. Not sure if I'm gonna get through everything because uh, one, I'm on coffee, so it's hard for me to manage not to talk through some of my ideas that are flowing when I listen to some of these videos. At first, I was just doing for inspiration, but I think that's for usefulness of finding things, you know, within a certain time frame that could prove useful, right? Something that we might not have heard of that we can discover together. Um, this Czech channel, I probably will change the name at some point. But for now, I go by the moniker of Air Jordan. Um, yeah, but I'm Marcus, but I go by Air Jordan. Um, don't know how brandable that is actually just my game tag, just to be real. So, all right, let's listen to this.
I'm Paul. I work in Oracle in the Java Platform Group. Um, this title is buzzword compatible, but I do promise you there is some substance to this that I hope to persuade you that we're building out a platform that has the facilities to build out machine learning libraries and machine learning applications. So let's plug in and go. So if you saw Mark's keynote, two primary goals of Java have always been to improve developer productivity and program performance. And if you look at it from the pain points of AI, that there's specific demands and improvements that we could think about towards those goals with respect to AI-like solutions, or HPC-like solutions, or big data-like solutions. They meet the demands for AI, these features that we're looking at, but they're also more broad. We're not going to specialize just for this narrow vertical. We're going to ensure these features are widely utilizable in other areas as well. And that's, I think, in one of the successes of Java is it doesn't narrowly sort of focus on one particular area. Like, we're not going to add XML support directly in the platform. As an example, I think Scala made that mistake because these things change over time. So the features I'm going to talk about, the features that only we can do in OpenJDK, Oracle, OpenJDK, the community there. They often require updates to the virtual machine, the language, and core library APIs. And crucially, some bridge the gap between the Java world and the foreign world. There's a lot of code out there that runs very well and executes very efficiently that we should be able to reuse if we can, and not reinvent it or re-implement it if you don't want to. So there are 4 features I will talk about in general. that I think are relevant to AI that were either in the Java platform or are future features that may end up in the Java platform. So the first one, optimal utilization of off and memory API in Project Panama are future features that may end up in the Java
I apologize. I thought I had to speed up the video, and I don't have it activated. So, sorry.
platform. So the first one we also mentioned at the keynote was the foreign function and memory API in Project Panama. You can use this for two things. One is to optimal utilization of off-heap memory between the JDK and something outside it. Zero copy is extremely important in some cases. And also better interoperation with native libraries than in JNI, like Mark showed you. So optimal utilization of memory is extremely important. Efficient productivity to how to get access to these native APIs is also very important. Next up, we have the vector API in Project Panama as well. And this effectively gives you SIMD programming in Java for optimal CPU utilization. You can think of this about enabling better number crunching. And what do machine learning things do? They crunch on numbers, often embarrassingly parallel dot product, using some clever floating point sort of representation that someone invented. And then there's value classes and objects in Valhalla. This will give you optimal utilization of memory on heap. And crucially, will enable more kinds of number. So we can think about float 16 numbers in the platform, for example. Or someone outside could add a bfloat 16 number. And it would look like a number to the existing numbers already in the system. And then there is a feature called code reflection I mentioned at the keynote, Project Babylon. And this gives you interoperation with foreign programming models. Such as, what's a foreign programming model? Well, it's a programming model that you code to GPUs like CUDA. Or it is the ONNX programming model that represent ONNX machine learning models. Or it's auto-differentiation of Java code. It's stuff we don't specify in the platform in terms of how it behaves. And we do not want to embed in the platform how ONNX models, GPUs work, how auto-differentiation works. We want to up-level this to let libraries do that kind of thing instead. And so this enables utilization of diverse hardware and better number crunching. It's all about number crunching. It's all about using hardware. It's all about efficient use of memory. And these things are general. They're not just related to AI. So what we're adding will help AI, but it's all broadly help the platform in terms of its efficiency. So the supposition is, I believe this to be true, Java is already mostly everywhere that AI needs to be. Do you agree with me? Maybe, I do. I would say that it's more so realistically for deployment of AI models than their actual development. That's true, most of it goes in Python at the moment. But I believe if we execute well on this, that we should anticipate that all AI shops grow up to be Java shops. Now, if you've heard this play on this, there was a blog by James Governor from RedMonk, and he said that I think it's all web companies grow up to be Java companies. So I believe that we can make this happen, that all AI companies grow up to be Java companies. A noble goal. May not achieve it, but I think we can get some of the way. So is it possible to build AI solutions without these features? Yes, of course. But it is harder to design, develop, maintain, and evolve. It's harder than it should be. So we need to address the pain points to make it easy.
One thing I noticed is that that article was from 2016. I'm just saying. Don't know how relevant that is, but yeah. But okay.
Easier to do so. So if there's one thing that you could take away from this presentation, is that the features I said, and also other features in the platform, interconnect, kind of greater than the sum of the parts. And I think this is enabling developers to build really powerful libraries and applications. I'm sensing this myself. And anecdotally, I'm finding that the modern Java platform is becoming really good to prototype these kinds of ideas with these features. Now, I understand these features, I can rapidly prototype them, but I'm seeing other people in our groups come in and onboard to these features rapidly and be able to make progress. And so that's not just these 4 features I talked about, but it's the language enhancements, it's the API enhancements, it's all coming together into a platform that I think is really powerful and can be used for AI solutions. So here's some examples I will go through on leveraging on features relevant to AI. So one area is, what is Java doing for GPUs? I'm not going to talk about this because Gary Frost over in the audience there is going to talk about this in the next session. And I've given the session details here. This is the Heterogeneous Accelerator Toolkit. And it's, we're thinking about how we can leverage GPUs in the architecture here. I think we've nailed the general architecture of how to solve this problem. And it uses code reflection.
All right. I'm going to add to pause for a little bit. I'm going to turn off my audio and my video because I'm eating. Let this play, and then I'll do commentary. Kill 2 birds with one stone. Oh, my audio is off. Wow. How long has that been going on? Yeah, I think I remember. Okay. I paused the video. I'm eating. I'm going to turn off the mic and the video feed and eat, and then I'll give my commentary. All right, let's do that.
The FFM API. I'll show an example of Llama model inference developed by someone from the Graal team in Oracle. And this uses FFM and the vector API. I will talk about an anomaly detection example implementing something called MSET2. It's a proprietary algorithm from Oracle, so I can't describe the details, but I can describe generally how it works. And that uses FFM API and the vector API. And as I showed in the keynote, there are ways to develop machine learning models in Java and execute or infer them. And that's what I'm calling Onyx script for Java that I showed. And I will show that demo again and more details in the code. And maybe it's an opportunity to ask further questions about that if you watch the keynote. And this uses code reflection and the FFM API. Of course, they use other things too. But this is, you can see the two coming together.
Wow. Did not realize I had the video paused for quite some time. All right, so I mean, he went over some code. It was actually very useful, but it's very high level, like what's happening in the memory and the heat. I mean, I could play it back, but I can give you a timestamp of that. So about 11 minutes in, he starts going over the memory, uh, basically how the API works and how you can use C inside the API to do native memory allocation. Um, Instead of using heap memory, which uses more resources on objects. So, here's the code. I mean, I'll just play it. I'll play about a minute into it. Let's see it. Let's go right about here.
We use JExtract to bind to the Bliss header. It generates some code to us, and then we implement on top the matrix API, like so. And that matrix API, then you can do all sorts of linear algebra with it. It's very straightforward. Here's an example of using this. If you were writing in C, this is how you would code using the Bliss API. So this is C code, ordinary C code. What it's doing is it's creating some Bliss objects for the matrices and filling them in with data and then doing a matrix multiply on them and freeing up the objects afterwards. It's fairly straightforward, but who wants to write code like this? I don't. Now, if you use the FFM API that's produced from JExtract, in effect, what you're getting is a C-like idiom in Java. So this is the equivalent program written in Java using the binding that Panama generated. Instead of using objects on the stack, I have to allocate them on the heap, allocate them on the native memory. So I allocate the obj structures which describe the matrix. I then create the actual matrix with all the elements, with the size of the dimensions of the matrix, and then I fill them in. In this case, I don't have to fill the matrices that are already zeros because the Panama APIs already did that for me through allocation, whereas in the C API, I had to do that. And I can call gem, but I still have to free up the objects that I allocated explicitly through Bliss. I can hide all this. I don't need to deal with this. I can hide it around a matrix API, where I create a new matrix with the sizes, I initialize them, or I get constant matrices of size 1, alpha and beta, of matrices of 1, and I initialize them, and I just call gem, and I free up the memory through the try-catch, like that. So you can see how we can write like C, but we can wrap it around in idiomatic Java code that everyone understands. And now I can start doing linear algebra. What is linear algebra? Matrix multiply. There's other stuff too, but it's fundamentally down to that. And I can call out to the Bliss native library and zero copy memory. There's no cost to it in terms of the memory copy, because all the memory is held natively on the heap, held natively, not managed by the VM. So the VM gets out the way. And I can leverage Bliss's very, very efficient matrix multiply algorithm. Does that make sense? Yeah. So onto the vector API.
Okay, let me pause it there. Yeah, so let the video go back into it. Not really what I was looking for. Very kind of high level. Um, Maybe it's more interesting. I can't remember the title of the video. It says Java for AI. So that my bad. My bad. It's more of them showcasing APIs and like how it will work out. But I'm not familiar with a lot of that. And really, the matrix part, especially, I'm not familiar. Uh, like doing memory allocation, things like that. Of course, it's fundamental. But anyway, show this stuff. Hopefully, this isn't a waste of time.
Hello to you all. I'm David
Hello.
Gerard and this is Pivot to AI. Today, let's feel the AI coding vibe. You can hardly get online these days without hearing some AI booster talking about how AI-based coding is going to replace human programmers. AI code is absolutely up to production quality. And by the way, you're all fired. But if AI is so obviously superior, show us the code. Where's the receipts? Say, where's the open source code contributions using AI? It's curiously absent. This week's hype example is Satya Nadella, CEO of Microsoft, and Mark Zuckerberg, CEO of Facebook, furiously talking up AI for programming on stage. The headlines say that 30% of code at Microsoft was AI now. Huge if true. Of course, Nadella didn't quite say that. What he actually said was,
say maybe 20-30% of the code that is inside of our repos today in some of our projects are probably all written by software.
maybe 20 to 30% in some projects, at least 3 or 4, maybe, who knows. Written by software, lots of projects use code generators. Probably, he's not sure either. This is a good example of CEO weasel wording, where you make a very hedged claim that's barely claiming anything, but it doesn't constitute a material misrepresentation as such. But then you let your media cheerleaders misrepresent you for you. You didn't lie, technically. Nadella would have asked his staff for something, anything, that he could say to pump AI coding on stage. And that's the best claim they could find that wasn't technically a lie. Mark Zuckerberg said on Dwakesh Patel's podcast, talking specifically about engineering at the Llama LLM project and not anything else at Facebook or Meta.
I would guess that like sometime in the next 12 to 18 months, the point where like most of the code that's going towards these efforts is written by AI. And I don't mean like autocomplete.
Of course, Patel's YouTube headline was AI will write most meta code in 18 months, which is not what Zuckerberg said at all. But let's assume the boosters are right and AI coding is so good here in 2025 that it is going to substantially take over the job of programming on live Facebook code that makes money and live Microsoft code that makes money. Again, huge if true.
I
So
like
if
this
AI
guy.
is such an obviously superior approach to serious code you make your money from, why don't we see it in any places we can actually check? Where are the receipts? Open source code is developed out in the open. You can see all the code, you can see every individual change. You can read the project discussions. Some of the best minds in coding work in open source. They know their stuff. If AI coding really is just technically better, they would be using it and recommending it. We should see AI coding all through open source. It's the one place we don't have to take some AI bro's word for it. But we're not. Ben Evans, who's currently at Red Hat, is a Java programmer. He's written several popular books on Java. Ben asked the obvious question, where are the code contributions to open source? Share some AI-derived pull requests that deal with non-obvious corner cases or non-trivial bugs from mature free and open source software projects. I'll also accept high-quality documentation that isn't just the sort of wasted space and slop that I always tell juniors not to write. No talk, no rhetoric. I won't respond to any comment that doesn't have a link to an accepted and merged pull request that was produced by an AI model. The closest response was one contribution to the Rails project in 2023, and that needed a lot of work before it was up to scratch. It wasn't a response to Ben, but there was also one experiment with AI coding in the Servo web browser project. That pull request went through 113 revisions before it was acceptable. It started with sloppy errors like a check condition being the wrong way around, the sort of thing a bot would generate. The general comments that Ben received were that experienced developers can use AI for coding with quite good results because they know what they're doing. But if it's an inexperienced developer, you're going to get bad results. And we knew this already. Some replies to Ben's question, show me the pull requests, complained that this question sets too high a bar. Non-obvious corner cases or non-trivial bugs from mature projects. They made out that this was unfairly high bar. I don't buy that. If all these big companies are shouting from the rooftops that AI is up to production code that the money can rely on, then zero open source contributions of substance is a glaring absence. Now, it is true that a lot of open source projects really hate AI code bots. There are many objections, but the biggest objection tends to be because people spam them with useless AI garbage. The curl project banned AI-generated security reports recently because they were getting flooded with automatic AI bug bounty requests. It was wasting their time. The Cockpit project decided to test how good AI code review was. They tested GitHub Copilot and Sorcery.ai doing bot reviews of human-submitted pull requests. Can it do that job? It turns out not. TLDR, a lot of noise, a lot of bad advice, and not enough signal, so we switched it off again. About half of the AI reviews were noise, a quarter bike shedding. The bots gave a lot of nitpick suggestions, or suggestions that were unfounded or even damaging to the code. They just were not helpful. More broadly, the very hardest problem in open source is not code, it's people. The fundamental problem of how to coordinate with others. One user of the LLVM compiler complained that his AI-generated pull requests were not being taken seriously by a compiler project where correct computer science and knowing precisely what the heck you're doing is profoundly important. The user considered it was the unpaid volunteer coder's job to indulge him. He even filed a code of conduct complaint against them with the project. This was not upheld, so he proclaimed the project corrupt. This is an actual comment that this user left on another project. As a non-programmer, I have zero understanding of the code and the analysis, and fully rely on AI, and even reviewed that AI analysis with a different AI to get the best possible solution, which was not good enough in this case. You can see why people just don't want to deal with this. But maybe we'll get a flood of obviously excellent AI-generated code next year. Thanks for tuning in to Pivot to AI, coming to you daily. Please, if you can, tell one other person about this episode, like and subscribe on YouTube, review it on the podcast apps, and I have a Patreon where you can send.
That's valid. This whole conversation was valid. Yeah, I'm glad I watched this video. I'm going to look at some more of his videos, and I'm probably going to subscribe. But the reason that that's so valid is because the first project that we did on the channel, right? I was not able to debug the code in order to fix that app, right? So maybe I can do it now, but maybe it's more important that I don't do it, right? Because coding has its limitations. I mean, it was working fine until it wasn't, and then I couldn't figure out why it wasn't working. Meaning, it ran into a runtime error, not a syntax one, but a runtime error. So my app wouldn't start, and I couldn't figure out why it would not start. And one of that's a fundamental skill of programming. Well, tech in general, really figuring out why something is broken, and then turning around and fixing it, right? And making sure that it works the right way. Um, so this could even become a debugging channel um, using I don't know. I won't even say AI, but um, I'm going to get better at coding, right? And hopefully we can do that together. That's kind of the main point. So one thing that I gained from this video is open source projects in general, not specifically AI, but I mean not AI generated code, but the actual AI, and then using, let's say in this case, Java, and trying to contribute. So, how fast can I get to, not even fast, but can I make something useful, either my own tool, or can I contribute to a project that's open source that is being used in some way, capacity, or can I build this skill to get to that level? And then other people will have to judge that, right? Because you do the repository commits and then the review, and right, it might get accepted, it might not, right? So getting to that point, it's very important. Um, yeah, because right now I'm bad. I'm not notoriously bad. I'm better than probably than most people, but not good enough to get to where, not good enough to make money from this. Good enough to make money in tech, but not necessarily programming. Um, like web design, I kind of consider that a little bit different. But I mean, like building a SaaS app, um, maybe even an AI chat agent type system. Some of the things I talked about in the channel, just in general. This is kind of it says 30 minutes, so I think we'll keep going. You see the point. But finding a AI related Java project or creating one, right? Um, and I mean, you can use AI to generate the idea or help you generate the idea. And I think I've had some in the past. And one idea comes to mind kind of immediately. And the idea is the asset generation for, I say Unity and Unreal, but it could just be cloud based, it could be local based, and pulling the files and then making a meaningful user interface. And not just that, having the proper backend for tooling. I mean, you can find these apps like the Unreal Store. You can find these apps in the Unity Store. But maybe maybe just a phone-based one, right? Like it doesn't necessarily have to be a part of that platform, if that makes sense. So yeah, that's my kind of go-to. I did have an idea of actually opening up a Java book and just reading it, right? That way we can kind of learn what I'm learning together. But I think I'm gonna stop this video here because I think that's the kind of the direction that I want to go right now. Building the fundamentals. I don't know um, I don't know if there's a problem with actually reading that book and streaming it, if that makes sense. So not necessarily streaming it, but recording it. So uh, actually, I will stop the video and then I'm gonna look that up and see if I can find anything. And yeah, seeing if I get like, I don't know, demonetized. Usually the video gets demonetized itself, but the thing is, I think it's useful. I think it's useful. I think it's useful meaning like I used to watch a lot of YouTube channels, and then they would show all the fundamentals, and like you would build from that, like Bucky's. I remember using Bucky's. There's Net Ninja. There's so many. There's so many. Um, but actually building something useful, right? To you, to someone, providing a service, right? Um, actually creating something that people use, you use, even if it's just yourself. Maybe that's the small goal, right? I build something that's useful for my community, I mean, right now in the YouTube community, or it could be whatever community you need it to be. But I'm saying building something useful. It's going to be the idea. Um, research and building something useful. To build something useful, we got to understand the fundamentals. Right now, um, honestly, I'm just going to be honest. I skipped a course because I've taken computer science courses before and I passed them. But the thing is, I didn't make a high enough grade to transfer. So now I have to retake the course because switch uh, universities. So that being said, it wouldn't carry over with the grade that I made. So I had to do better, right? And this is going to be hopefully helpful for me and then helpful for you as well. So until the next video, Air Jordan out.